Hello, this is Mr. Huff, and I want to just walk through this report assignment. And I see that I misspelled something here. Yes, I did. So this is going to be the composite report for virtual students. The first thing I have in here is probably going to be this video that I'm making right now. The second thing you'll see is writing expectations. I have some students that are struggling with written communication, and I want you to be aware of the process that I recommend and expect. All right, so you can't do this until you've completed the the composite analysis for virtual students using Google Sheets. So sort that data in different ways, find some averages, find some low values, high values, look for trends, look for differences, look for similarities. So I want you to identify some characteristics to compare looking at the data. And this is something that you would have to do in real life. Sometimes you don't know what it is you need to talk about, but you have a whole lot of data and you need to summarize that, explore it, and come up with observations based on the data and what it's telling you. Okay? So I want you to look at that and look for some comparisons and differences and that sort of thing, and then you can talk about those. Make sure that when you're doing comparisons that your samples have only one difference. For instance, if you want to compare the type of foam, the 1" by 2" versus the 2" by 2", you need to make sure that they have the same type of fiberglass applied. Okay, so you don't want to compare a unidirectional for one and a bidirectional for the other, and then also have different types of foam. That's called multivariate analysis, and it is outside of the scope of this class. So make sure, just like in a grade science class, you have everything is the same except for one difference, and that's what you're wanting to do. Also, if you have multiple samples of the same item, I know that we've got several bidirectional 2x2 pink foam samples. Calculate an average of those and record the min and the max so we have some understanding of kind of the boundaries and what the average is. Okay, everybody has to compare the modulus of elasticity for bidirectional and unidirectional. We had the class guess which was going to be stronger, the bidirectional or the unidirectional, and everyone except one person guessed it was going to be bidirectional. Now it's time to let the data speak for itself. So we're going to see what you find when you analyze the data. All right, the remaining comparisons are your choice. For instance, the pink foam versus white, the 1x2 versus 2x2, fiberglass and without fiberglass, kind of what the comparison is. So look for interesting observations in the data. Let me also say that the main way we can compare these is going to be the modulus of elasticity, because it considers the force and the length and the deflection and the moment of inertia. You could also discuss, ultimate yield strength, but that is not as useful as a properly calculated modulus of elasticity. All right. So what you're going to do is you're going to make some comparison slides. You need to have a table on there that looks like maybe like this. Let's say we're comparing bidirectional to unidirectional. This table didn't render the way I want right now, but you might have the average modulus of elasticity and the highest and the lowest values here. So you can look at those two very clearly compared to each other. And then another discussion I want you to have on this same slide is look at the data in the table and tell me what it means. What is that data saying? And use nice clear sentences and refer to the numbers that you have in the table to support your claim. Is one better than the other? Is there virtually no difference? What is it telling you? The data has to tell us something. Okay, and I want to know what you think it is saying. You have to do at least 3, but if you see some more that you want to explore, feel free to do more. So at least 3 comparison slides that include a table and a discussion of what the data says. All right. Then you're going to add 4 more slides that use a 2-column layout for these conclusion questions. When should you use composites in an aerospace design? When should you avoid using composites and choose other materials like metals instead in an aerospace design? So what we want to think about is applications. Put yourself in the shoes of an aerospace designer. Why would you want to use composites? Why would you want to avoid composites? You may have to do some research, but give me your thoughts in your own words. All right. And then why are composites crucial in aerospace design? It's just kind of a broad statement of why do we rely on composites in aerospace? And then using your imagination, you think of an example of something that you use, some object, some item, some product that would benefit from the use of composites, and explain why you think so. So just kind of discuss, hey, I think it would be great if we made markers out of composite materials, and tell me why. So when you're done with all this, make sure you've got everything covered. Make sure your name and all that kind of stuff is on it somewhere, that you have some dates and stuff recorded somewhere, and then export it as a PDF, and you're going to turn that in here. All right. Let me know if you have any questions via email, or you can also join the Zooms, and we can discuss it there. All right. Good luck with this. Thanks.